doing a number of videos that touch on the issue of physics and cosmology, because those are subjects that I like very much, and they are subjects that I've come to have some views on, which are consistent with a theory that has been offered, and actually it's been offered ever since theorists began to believe that our universe originated some 13.97 billion years ago in a Big Bang-like event that brought all of reality into existence. Everything that we see, every star that we see in the sky, everything that was created, as far as we know, was created at that time. So that's according to modern theory. But there's some very difficult aspects to modern physical theory, and especially the theory that has come to be the most popular, or the most well-established part of the modern physical sciences, and this is called the Standard Model of particle physics, and it explains almost everything that we could want to explain scientifically about nature. And that was created by Steven Weinberg, a physicist from University of Texas, and Abdus Salam, and Sheldon Glashow of Harvard University. The three of those gentlemen together conjugated the theory of the Standard Model, explaining the electromagnetic force, the weak nuclear force, and the strong nuclear force, and leaving the explanation of gravity as something that has not yet been explained. The graviton remains untheorized, but the essence and importance of that theory is that it leaves unexplained the reasons for the fundamental parameters in nature. In the Standard Model, there is a number of constants that appear and that mathematically have to be part of the theory. For example, the fine structure constant, but it leaves those measures as empirical, as measured empirical numbers that physicists have produced based on, they have kind of stirred those numbers into the theory, if you will. They have not given the underlying logic or explanation for those numbers being what they are. For example, the proportion of weight of the electron to the positron. They both are equal in mass, and hence equal in weight. But mass and weight are actually a little bit different, and they have to do with gravity. But we can say the mass of the two particles is equivalent. And the mass of the neutron inside of a hydrogen atom, which has an orbiting electron, the mass of the proton and the neutron the neutron is slightly lower in mass than the proton. Why is that the case? What theory gives an explanation for why that is the case? And there has been a theory that has been offered by Dr. Ernest J. Sternglass, a physicist and theorist who was associated with the Perimeter Institute. And he has given us the explanation that the very Big Bang itself was like a nucleus within a larger atomic structure that is the entire cosmos that we have. And so in that book by Dr. Ernest J. Sternglass, called Before the Big Bang, on the origins of the universe, he gives the explanation for why the mass of the galaxies, or of each galaxy in the cosmos, is what it is. He gives the explanation for what the logical reasons are for the fine structure constant being the exact number that it is. And so he lays the foundation for physicists today, like Robert Wald, we'll pronounce his name, I believe he's German, so Robert Wald of the University of Chicago and others, to now take the theory and advance the sciences by actually building on its foundation and then presenting, along with Dr. Weinberg, Dr. Hawking, and a panel of physicists that we need to bring together, we can bring an explanation to almost all the phenomena, and this will be an advance of the Standard Model, and it will produce the completion of the Standard Model and the reasons for the logical interconnections and explanations of each number in it. For example, the Planck scale, mass, time, and length, and everything, and the structure of galaxies. But the primary and most interesting thing about that theory is that the whole universe is an atom that is interacting within itself, as they say. And so the interaction of this atom, if it could be seen from without by a god, it would be as if that god were looking through an electron microscope at the atoms that are seen today by physicists when they use such an instrument. An electron microscope is just this really complicated microscope that takes light quanta, or light particles, and it impinges them upon objects so that the atomic scale, so that something at the scale of the atom, at billions, trillions of a meter, can actually be determined to exist in a certain space, time, location. And so we make measurements using the electron microscope and the electron tunneling microscope. And in the future, we're going to seek to make an electron-positron microscope that even shows us these lower levels of reality and the higher levels of reality in the cosmos with the galaxies. We're going to seek to make telescopes on the basis of the positron and the electron that can actually give us more precise measurements of those as well. And this will all be based on Sternglass's idea, but it's not Sternglass. Sternglass wasn't the only one who created it. George Gamow of Russia, Lemaitre, George Lemaitre was the one who founded the idea of the Big Bang. But one of the most important things to anticipate about Dr. Sternglass's theory is that it gives us a more precise estimate of how old our cosmos is, or how long it takes our cosmos to do an entire cycle from birth to death to rebirth, which Dr. Sternglass thinks goes on forever, because we live in a cosmos that never dies. It's an infinitely existing and recreating pair of electron and positron. So they're just two particles of which the entire mass of all the heavens, all the stars, all the planets, all the Earths out there are made of. They originally came out of the movement of those two particles together, arcing through each other for 16 trillion years. So Dr. Sternglass is telling our present sciences in that particular book that the universe has existed for 16 trillion 13.97826 billion years, not for just 13.7 billion years. It's much older than they had thought it was. And Dr. Sternglass, after speaking to Einstein, theorizing his whole life, working at places like Westinghouse and improving instruments that look into the cosmos, telescopes. He designed telescopes and worked in the industry with physics and electrons. His very hands and eyes every day were working with electrons as he built and developed a theory of the cosmos over the course of about 50 years of reflection, and then published it in the 90s under the title that I gave, Ernest J. Sternglass, Before the Big Bang, on the Origins of the Universe. Check it out.